Information that we collect can be stored and reported in different ways. One method is using tables, which can be helpful for calculating probabilities. In example 12, we're told that left-handedness has historically been discouraged or even vilified in certain cultures. Currently, about 12% of the US population is left-handed, but around 1900, the rate was only 3.5%. The table below describes the distribution of a random sample of 118 individuals, organized by the time period in which they lived and whether they were right or left-handed. So we can read this table either left to right or up and down. As we read the rows across, we see the numbers of people who were alive today and are either right or left-handed, and then people who were alive in 1900 and were either right or left-handed. Or we can look vertically at those columns to see how many people were right-handed, which time period they lived in, and the same for left-handed. If we let event A equal the person is alive today, and B equal the person was alive in 1900, R equals the person was right-handed, and L equal the person was left-handed. And if we assume a person is selected at random from this sample, then we want to complete these following questions. We want to find the probability of B, which means we want to find the probability that someone was alive in 1900. We'll just use P of 1900 as a shorthand there. In this case, there were 59 plus 1 people who were alive in 1900, and we were told above in the problem that 118 people were sampled. So our probability that a randomly selected person was alive in 1900 would be 60 divided by 118, or 0.5085. In part B, we want to find P of R, which is the probability that someone is right-handed. Looking at our chart again, we can see there were 50 plus 59 people who were right-handed. Still out of the 118 total. Well, let's say equals first. So adding those together would give us 109 out of 118, or a probability of approximately 0.9237. In part C, we want the probability that someone was either B, alive in 1900, or right-handed. Looking back at the table, we can identify everyone who was alive in 1800, and we can identify people who were right-handed, and we see that we have some overlap between those two regions. We want to make sure we're only counting each collection of people once. So in this case, we would select the 50 people who are right-handed, plus the other 59 people who are right-handed, plus that one extra person who was alive in 1900 but left-handed. Because that or statement means we're happy with either of these two outcomes. So our probability would be 110 out of 118, or 0.9322. In part D, we want to find the probability that someone was alive in 1900 and was right-handed. Now we need both of those statements to be true. And in this case, the table helps us zero in on those 59 people who meet both of those conditions. So our probability would be 59 over 118, or approximately exactly 0.5.